Let's start with this. So in this one, what we are going to do, given the Boolean expression, we are going to draw the logic circuit and then we'll construct the truth table. So we'll start the first one. It's Q equals within bracket A plus B plus B. First, identify how many inputs are there. So in this particular case, we have two inputs. So first we'll recognize that, okay, we have two inputs, A and B. There are two, so the two inputs, and then you know that with the plus, we know that we have to have two gates, two OR gates. So let's start with the first one. So we'll have one OR gate. Yes, this is the one. Yes, we will have A plus B here. Then you have to add another B. What do you have to do? Yes, we have to have, so this is one side. So this is one side, we should get A plus B, and we have to have another okay. So one input already we have given, right? So we have to select B from here. Okay, so B. So this is A plus B. So this is B. So then now we can have this Q. Now let's double check the answer. So we have input A, B, and this is O gate. O means Boolean addition. So we will get A plus B. From this side, we are getting another B. So from the top, we are getting A plus B, B. So again, another O gate. So Q, we can say, okay, one side we have A plus B plus other side we have B. So to draw the truth table, we need to A, B, two inputs. And then we need to find out A plus B. Finally, you have to add another B to this one. So we are going to have labels A, B, A plus B. So Q will be A plus B plus B. Right now, since we have two inputs, we can have four states. That's 0, 0, 0, 1, 1, 0, 1. So you see the pattern. So this one we have 0, 1, 0, 1. So we have two zeros and two ones. So 0 and 0. So 0 plus 0. So that's 0. 0 plus this is 1. This is again 1 plus 0 is 1. And you know this is 1 plus 1. This is O. So that means that is also 1. So now you have to add another. So this is A plus B. So now we have to add B. So we have to add these two together. So 0 plus 0, that is 0. 1 plus 1 is 1. 0 plus 1 is 1. And 1 plus 1. Right. So in a way now you see Q is equal to A plus B plus B. Irrespective of what B is, finally the answer same as A plus B. So instead of this circuit, you could have keep only A plus B because you are getting the same answer. Right. Okay. Let's do another exercise. Okay, so this is the second question. So let's look at Q equals A dot B. Now, question 2, we have to draw A dot B. So which means we have to have again two inputs. There are two inputs and then they are A and B. So let me put A, B. So we have to have two inputs. Now here we have one gate. It should be AND gate. And then we will get only A. From the other side, we need like AB together. Right? So one side we need A. We have to have AND gate. Right? We have to have AND gate. But for that, we need AB again. Right? So what I'm going to do, so before we connect to this one, we need another AND gate. So I'm going to take A from here. So we will have A, B, A, B. Right? So now you see from here we will get A, from here we will get A dot B, and finally we should be getting Q. And if you look at here, so we will have A here, right? So this is A, this is A, this is B. So this is AND gate, so it should be A dot B. So from here we will have A, and here we will have A dot B. So Q should be A dot, we have A dot B. Right? The next one we have to have is we have to have the truth table. Now truth table also we have two inputs, so we can take A, B, and then on the other hand we can have A dot B because we have to calculate A dot B, and then we can multiply with A dot B. So A and A dot B, right? So that's what we could do. So let me draw the values that we need. Now for this one, we are going to have, right? Okay, A, B, and A dot B, and Q equals A dot B. Right. Now let's see. Now here we have A, B, two inputs. We have two inputs. So that's why we have 0, 0, 0, 1, 1, 0, and 1, 1. So this is Boolean multiplication. So when you multiply 0, 0, 0, 0, 1, 0, 1, 0, 0, only when we here we will get 1. Now we have A dot B, and we have A. Again, you have to multiply these two together. So 0, 0 again 0, 0, 0 again 0, 1, 0 again 0, 1, 1. We will have 1. We will get the same answer as the previous case. Okay, so I hope you got this time. So this time, there are two questions I will give you. You could try. So the first one, we have A plus B dot A dot B. So again, we have two inputs, but in this one, slightly change. I'm going to have like three inputs, and I'm going to have A dot B bar, B dot C bar, A dot C bar, and I will put a total bar, right? This. Okay. So let's start. So let's start with the third one. In third one, what we had, Q equals A plus B dot A dot B, which means we have two inputs and then we have three gates. So how do you know? Like, you know that here we have one A plus B, here A dot B, and then another dot. So that means we have O gate here, AND gate here, and another AND gate here, right? So if I start drawing it, so inputs are that this is the third one. So inputs are, we have AB inputs, right? So one side we have to have O gate. So we have to have O gate to connect in these two, and then AND, right, combining these two, right? So which means we can have A from here and then B from here. So this is, A plus B. That's the output, right? So this is the output, right? Okay. At the same time, then A dot B, so which means I'm going to get an input from here, right? This connector will show you that I'm connecting there, right? So there is A, and I'm connecting from here. So we have B, which means here we will get A dot B. So these two I need to combine using another AND gate. So I'll connect the output from here to here and the output from here to here, right? So that we will get Q. So the inputs are, we will have A. So here we will have B, so that we will get A plus B here. From here also we will get A, this is B, so this is A dot B. So from the top for this AND gate, we are getting A plus B, here we get A dot B. So the Q will be, right, A plus B dot A dot B. Okay. The third one, to draw the truth table. So we have to have A, because B, we have two inputs. So we'll have 0, 0, 0, 1, 1, 0, 1, 1. We have four states. Then we need to get this expression, I'm going to separate out A plus B and A dot B. And finally, I'm trying to multiply the values of these two columns, right? So that's why we were here. So let's start. So if you, first of all, it's O gate, that means Boolean addition. So this will be 0 plus 0, 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. Then Boolean multiplication, A dot B. So 0 is 0, 0, 0, 1 is again 0, 1, 0 is 0, 1 and 1, it will be 1. The next one would be like you get these two columns, multiply each other to get the final answer Q. So this is again 0, 0, 0, and 1. Yes. So it's the same as A dot B. If you look at the two columns, the same, which means this complex circuit with 3 gates can be reduced into one single gate, isn't it? So the output will be the same. So that means this expression is same as this one, which means another way you can see logic gates can be used to simplify your circuits. But when you further learn about the logic gates, you will learn like there are other ways to simplify the gates. But for the time being, so we can even draw a truth table to identify the simplified circuit. Okay, so let's move to the next one, right? I'm going to first of all draw this circuit, and then we can discuss the truth table. So let me start with the fourth one. So fourth one, right? So we will have A dot B, B dot C, A dot C. So there are 3. So that means 3 inputs. So I will put in this way. This is another way to draw, right? So we will have A, we will have B. I'm going to get lines like this to say that, okay, so we have A, B, C. Then we know that we have to combine A, B together. So I'm going to draw, this is NAND gate, right? You have multiplication and complement NAND gate. you are combining A and then you are connecting B, right? Then we have BC, another NOR gate, sorry, NAND gate. We have B, we are connecting B, and then we have C. Then finally we have AC, another NAND gate. Yes. And these three, if you carefully look at, it's a plus, and then you have bar complement, which means no gate. So all these three outputs connect using no gate. So this line comes here, right? So this will be key. So now let's look at the outputs. Yes, we have this side, we have A, this is B. So this is A dot B bar. Then here we will have B, we have C. So this is B dot C bar. So this is A, this is C. So this is A dot C bar. Right, then you combine the addition and complement. So which means A dot B bar plus B dot C bar plus A dot C bar. And then you have to get the complement of all these three. So which means we are getting this. Now to draw the truth table, we should know that there should be a 3 inputs, right? And then you have to find A dot B bar, B dot C bar, A dot C bar, and then you get the complement, right? We have 3 inputs in this particular case, A, B, C, and we want to find out A dot B bar, B dot C bar, A dot C bar, and bar. So you can actually remember this one, or you can handle this, mentally. You can, multiply and get the complement. But, to make it easy, I add these 3, but, if you're capable of doing that, you don't need to, put these, 3 combinations. You can save some space. But for me, I will start from here. So the first thing is we need to get the AB, and we have to get A dot B. That means we have to get the multiplication. So A is 0. That means the first 4 will be 0 anyway. And then next one with B, so we will get 1, 0, it will be 0, 1, 0, again 0, 1, 1. So these could be ones. So if this is AB is 0, 0, 0, 0, 0, 0, 1, 1, we know complement of this means the opposite. So that means if it is 0, we will get ones. And finally, we have 2 zeros. Similarly, if you multiply BC together, so this will be 0, 0, 0, then we will have 1, and then we will have 0, 0, 0, we will have 1. So if you have 0, 0, 0, 1, 0, 0, 0, 1, complement of this one is 1, 1, 1, we will have 0, 1, 1, 1, we will have 0. Similarly, now if you say AC, again we have 4 zeros because A is 0, then we have C, 1, 0, 0, then we have 1, 1 is 1, again 0, then we will have 1. Right? So again, we will have 1. Now complement of this is, so you have 4 ones, right? 4 ones, then 1, 0, we will have 1, 0. Now I think we got AB bar, BC bar, and AC bar. We got these 3. Now we have to add them up. It's easier. So we will get 1, 1, 1, 1, 1, 1, 1. Finally, we will have 0. Why? All the three are inputs 0, then only you will 0. And then finally, you get the complement, right? Opposite of this. So that means we'll get 0, 0, 0, 0, 0, 0, 0. And this will be 1. Okay. Now, what can you tell about this? Simply, the answer would be this 1 means what? What is this? This is simply a multiplication of ABC. If you just multiply ABC and C, so we are getting the same result. So this complex circuit could be implemented using a single gate and single AND code and gate would be enough to represent this one.